Hi, everyone. So thanks for joining us for the Abscopal debate. I'm Elle. I'll be moderating. So just as an overview for the format, we'll have our speakers, Drs. McBride and Dr. Welsh, introduce themselves. They'll give a little bit of background for themselves. And then I will briefly present a case with an audience poll just to set the stage for the debate. We'll repoll you at the conclusion of the debate just to see if the audience was swayed one way versus the other. So Dr. McBride is arguing the negative, and he'll have about 10 minutes to present his argument. Dr. Welsh will have 20 minutes to defend the affirmative. And then finally, we'll end with Dr. McBride, who will finish with a 10-minute rebuttal. Just if you could type your questions in the chat, we'll get to them in the last about 10 minutes or so of the session once the debate concludes. So Drs. McBride and Welsh, if you could each unmute and give us a brief introduction for yourselves, and I'll present the case.
I guess I can start. I'm Sean McBride. I'm an associate attending at Memorial Sloan Kettering Cancer Center. I'm chief of our Manhattan services, and I treat both prostate cancer and head and neck cancer.
Jim Welsh, I'm a physician scientist at MD Anderson. I run the immunoradiation initiative and really interested in trying to figure out how to combine immunotherapies with radiation in various settings. So run a lab, do preclinical work and a lot of clinical work, and also drug development. So glad to be here.
Thank you both again for being here and participating in the debate. So I'm going to present just a brief case for the audience, again, just to set the stage. So let me go back. So this is a 65-year-old. He has metastatic renal cell to the lungs and mediastinal and hilar nodes. He's been on nivolumab and lenvatinib with good partial response, and essentially referred to discuss SBRT to residual lymph nodes with the goal to enhance efficacy of immunotherapy treatment, aka abscopal response. So this was an actual referral that we had received at Stanford. So this is just a very brief HPI in 2017, diagnosed localized renal cell, received nephrectomy, no adjuvant treatment. 2019 had biopsy-proven recurrence, so presented with a 4-centimeter right upper lobe mass, multiple smaller bilateral nodules in the lungs. Was started on Ipi-Nivo, had good response, and then was on maintenance Nivo. Repeat imaging showed enlarging avid mediastinal and hilar lymph nodes and lung nodules. So lenvatinib was added with excellent response, unfortunately complicated by some side effects, fatigue, and poor appetite. So he was started on steroids, which he continues today. And then repeat imaging showed stable residual disease. So he had 7 small lung nodules, residual 4L node, and a residual right hilar node. This is just some imaging. It's going from right to left. So you can see that once lenvatinib was added, there was decreased size in the right hilar nodes. This was a PET scan, and then a repeat CT scan showing response to lenvatinib in the hilar node, as well as this 4L node is a little bit smaller. And then on the most recent imaging, this is just 3 of the residual lung nodules that are shown. So a total of 7, and these are just representative slices for 3 of them. So you see him in clinic, he's doing really well, but he does have some mild insomnia and decreased extremity muscle mass, possibly from the prolonged steroids to manage the lenvatinib side effects. Physical exams also consistent with that. He has some mild Cushingoid appearance, otherwise unremarkable. So what do you recommend? So here we'll just poll the audience. I made it very simple. I had some other options initially, but I think just to keep it very simple, dichotomous, would you radiate for abscopal or would you not radiate? And I'll just give maybe 30 seconds. Maybe less than that. I don't think you need 30 seconds. All right, so about 50-50. All right, so I'll stop share. We'll start with Dr. McBride, who again is arguing the negative, has 10 minutes. I'll keep time. I'll just kind of call out when you have 5 minutes left, 1 minute left, and 0 minutes left. I won't be a stickler with the time, so just try to finish.
You guys see my screen?
Yeah, you're good.
All right. Is this in the presentation mode? Let's see. There we go. Is that better?
Yeah, perfect.
All right. So I am presenting the negative, which I'm happy to do. Abscopal, schmabscopal. So just to define the contours of the debate, what is the abscopal effect? Very simply, it is the systemic immune response precipitated by local radiation to a limited number of lesions, resulting in regression of distant non-irradiated lesions. So obviously, local immune stimulation by RT monotherapy rarely ever results in systemic tumor rejection. We have good data from a recent meta-analysis that looks at all of these. There's a variety of preclinical there's a lot of preclinical data that argues for the combination of focal RT with anti-PD-1, anti-PD-L1 therapy and anti-CTLA-4 therapy can result in enhanced abscopal responses relative to either treatment alone. And there's certainly very plausible biological mechanisms that have been fronted to explain the preclinical data that has been found to date. But I think the big argument, the crux of this argument is there any prospective randomized data that demonstrates that this occurs with any frequency in relevant clinical settings? And my short answer is no, no, there's not, in my opinion, and I want to run through the data here. So the first trial that came out was the NKI trial, Pembro RT. This was, I think, a robust phase 2 trial in stage 4 recurrent NSCLC. Patients were randomized to SBRT followed by pembrolizumab or pembrolizumab alone. So, important to note, this was sequential treatment. The SBRT came before the pembrolizumab. The primary endpoint was objective response rate. And there was, when you look at the primary endpoint, there was a trend towards significance in terms of the ORR. And you can see the p-value there, you can see the absolute numbers there. But when you look more closely, when you delve into the trial, you find, which is not infrequently the case with small RCTs unless you stratify by the prognostic variable that's really most important when you're looking at NSCLC and Pembro PD-L1 status, you'll find that you can, by chance, have imbalances in these key variables. And that is indeed what happened here. There was a substantial imbalance in PD-L1 status that favored the experimental arm, the Pembro RT arm, in a way that probably, frankly, completely confounded the data. Now, so when you adjusted for that, you didn't see that benefit. Now, they looked at PFS and OS. The test for interaction was significant when you looked at whether the treatments differed. So this was an attempt, I think, to sort of salvage the hypothesis, to come up with an explanation for maybe in a subgroup you'll find some benefit. So they looked to see whether there was an interaction between PD-L1 status and treatment arm. And now, despite the fact that the test for interaction was technically negative, they looked closer and they found that there was a benefit for PFS benefit for SBRT and Pembro in the PD-L1 null arm. And they looked again at OS and they found a similar benefit. But technically speaking, when you have a negative test for interaction, you shouldn't then delve into the subgroup to look for whether there is differential impact of the experimental arm versus the control arm. So you gotta ding them a little bit for this second look. Ultimately, in this phase 2, the first phase 2 that was published, in an unselected population with M1 NSCLC, there was no benefit to SBRT added to Pembro. The trial did not meet its primary endpoint. Now, additional study, the authors concluded may be warranted in the PD-L1 negative cohort, and you'll see this is a repeated theme in these trials. We try to look for a sort of hypothesis-saving subgroup that might benefit. The second trial I will highlight is our own trial from MSK. This was in M1 head and neck squamous cell carcinoma. Patients were, here we did stratify by what we thought was going to be the primary confounder, which was virus status. We enrolled not only head and neck squam, but some MPC patients, and stratified by virus status. Primary endpoint, the same. It was ORR. Treatment here a little bit different insofar as we started first with the nivolumab, and then in between cycles 1 and 2 of the Nivo, we started the SBRT, and that was 9 gray times 3, similar dosing to the NKI trial. The arms were well balanced by virus status. They were well balanced by PD-L1 status. So we kind of lucked out on PD-L1. It was well balanced. And again, this trial was negative. There was no difference in ORR, no difference in PFS, no difference in OS. Now, there was a numerical superiority in objective response rate in the virus negative patients. So again, we sort of had our hypothesis saving subgroup, but the primary endpoint was negative. Some hint of benefit with SBRT with Nivo in the virus negative patients, but that was very much a post hoc conclusion. Next trial, it's the CHEERS trial. This was reported at ESMO this year. Again, this was multiple histologies. Patients were randomized 1-to-1 to IO of choice versus SBRT, similar dosing. Again, this was the Nivo, or the IO was started first, again, compared to IO alone. Primary endpoint was iRECIST, progression-free survival. Well balanced in all relevant variables. And there was absolutely no hint of efficacy. This, again, was a negative trial from Pete Aust's group. Best overall response, not the primary endpoint, but secondary endpoint, again, no benefit. So their conclusion was in the addition of subtotal multi-site SBRT to ICI monotherapy in a variety of histologies did not benefit in terms of PFS. Their primary endpoint was not met. The next trial is Jim's trial. This is M1 NSCLC, phase 1 lead-in with a phase 2 randomized component. Patients were randomized to Pembro alone versus Pembro and RT. Now there were 2 RT dosing regimens. I think it was investigator's choice. Primary endpoint was ORR, as most of the previous trials have been. And again, there was no difference. This was also a negative trial. There was no difference in ORR. There was no difference in PFS. Again, we have our hypothesis saving subgroup of in the PD-L1 low expressors post hoc, but maybe there was a benefit there. But again, conclusion, there was no difference in the primary endpoint. The primary endpoint was not met, maybe in the post hoc immune cold. Then we have Jim and Williamson's meta-analysis. Now, I will take a little issue here. Should the meta-analysis have been conducted? Now, both trials were adequately powered for a 30% difference in ORR. We know ORR poorly correlates with OS. Why look for even smaller differences in ORR? The other point I would make is these were slightly different populations and slightly different treatments. There was differences in newly diagnosed versus previously treated between these 2 trials. So they were dissimilar populations. There was difference in the number of sites treated. In Jim's trial, they were treated multiple sites. 25% of patients had multiple sites treated. In the Pembro RT trial, it was 1. There were differences in RT doses and timing. I think looking at whether there was substantial inter-trial heterogeneity, it would have been good to look at the random effects, not fixed effects model. That's a little bit inside baseball. But the bottom line, I would say, take away from the meta-analysis is that after adjustment for PD-L1, which is the relevant confounder, there was no difference in PFS or OS. Now you looked at the subgroup here of Pembro plus radiation in the 50 gray and 4 fractions, but I would argue that because these weren't randomized, this was investigator's choice, I would just have pooled this and looked. But my take home is no benefit here in PFS or OS in this meta-analysis. And finally, and this I think is a great trial by John Schoenfeld, in M1, so this is essentially in an M1 NSCLC patient population who were progressing on prior anti-PD-1, PD-L1. So this may be more of a more immune cold cohort. They were randomized 1-to-1 to receive Durva and Tremi and either low dose RT or hypofractionated RT or Durva Tremi alone. And this was a stone cold negative trial. No difference in PFS, no difference in OS. Conclusion, the primary endpoint was also not met. And this is consistent with John's other trial in M1 colorectal cancer, showing no benefit of RT added to IO. And John had a third trial in the same area, looking at RT and IO in ACC, no benefit. So my summary here is every randomized controlled trial evaluating the abscopal, formally evaluating the abscopal effect with IO is negative. Now there's a variety of hypothesis-saving conjectures, incorrect timing, incorrect drug, and incorrect cohort. Now I think the Schoenfeld trial undermines the arguments that it's drug, because you hear a lot of arguments, well, maybe CTLA-4, that might have been the right drug. Yes, it was in a patient population progressing on PD-1, anti-PD-1, anti-PD-L1, but the addition of CTLA-4 with radiation didn't save these patients. Incorrect timing. I think the Thielen trial undermines that argument because that was a sequential negative trial. So, you know, and the cohort argument, the argument that maybe it's best in immune cold. John's trial, which was presumably more immune cold because they weren't responding to PD-L1, PD-1, and Jim's own meta-analysis with the NKI group showed that despite some initial suggestion that the PD-L1 low patients were going to respond, it didn't pan out in the meta-analysis. So there's not a lot of hypotheses left to save this idea. So in my opinion, it is better to focus our future trials on comprehensive SBRT, because I think that just relies on additive impact. We don't care whether the IO and the RT are acting synergistically. We just want to control the progressing gross disease or the upfront gross disease. So that is my anti-abscopal argument. Thanks, everybody.
Thanks, Dr. McBride. Okay, so now on to Dr. Welsh. You have 20 minutes to argue the affirmative. I'll call out time again for 10 minutes, 1 minute, and at 0 minutes. Again, I'm not going to be a stickler, so just try to finish around 0 minutes.
Okay, that was a great argument. I really have my work cut out for me, so watch out. No, that was a lot of fun. So good job there. These are my disclosures and my financial conflicts of interest. You know, I think the field of radiation oncology is really at a massive turning point. You know, when I went into the field, stereotactic was just getting invented, and it was a really exciting field to see stereotactic go forward, biologic targeted drugs. But now with immunotherapy, like if radiation doesn't adapt and keep up, I think the field will die, because we're at a time point now with cell therapy where you can give one dose of a treatment and cure people systemically. As such, the role of local control that radiation provides is really starting to become less important. So I hope the field can figure out how to work with this and move forward. I think it's at a pivotal, very exciting point, and it's you, the residents, that'll be taking this forward and leading this charge. So I wish you good luck with this work. You know, just historical perspective, right? So, you know, we developed a bike to move us faster, but could you develop a bike to move us, right? And I think that's very analogous to the abscopal concept. So Dr. Kavanaugh, who pioneered this with Dr. Timmerman, developed stereotactic, and I was lucky enough to rotate and learn stereotactic from him. But now, could you take that stereotactic that's great for local control and make it a vaccine and get systemic responses throughout the body? That's a heavy lift and something very interesting. You know, just like Thomas Edison said, you know, it took 2,000 ways to figure out how not to make a light bulb before he made it. And I think what you're seeing in these early trials is how not to do it. We're learning a lot. There's a lot of variables, and we're learning what's working and what's not working. So I think it's important to break these studies apart, look at them, and try to develop better studies that give us a chance of being positive and showing how radiation adds value. Now, I view radiation quite differently, I think, than most people. I really believe radiation is an immunotherapy, and we've kind of not sold that fact and realized that. If you look at this experiment on the left, you get high cure of animals with 20 gray radiation. But if you do the same thing in a nude mice with no immune system, radiation doesn't work. How can radiation not work because of the immune system? Well, that small effect is the radiation, and that bigger effect is immune. And why is radiation immune therapy? Because we're taking advantage of 1 million years of biologic evolution of how we fight viruses and bacteria. If there's DNA in the cytoplasm, that causes a massive problem. It causes C gas, sting, interferon, inflammation. and produces an immune response. And when you irradiate a tumor and damage the nuclear DNA, it goes to the cytoplasm and messes up the mitochondria that activates a sting interferon response, just like bacteria or COVID. And that's what we're doing. So how does Abscopal work? You irradiate a tumor, antigen release, antigen presenting cells take that up, activate T cells that go back to the tumor you're treating. So that's why you need an immune response for the ones you're treating, but they can go systemically too and address distant disease, which would be the abscopal. Now, as we do this, and I study this a lot in the lab, I have a group of PhDs in immunology that we really try to look at the pieces. I think immunogenic cell death is important, which we can do with radiation, but can also be done without radiation. We can do intratumoral injection, other things like NLRP3. You need to deplete the Tregs, which blunt the response. You need to help your dendritic cells. You need your lymphocytes there. You need to have T cells for immune therapy to work. And then you need to address exhaustion after they're activated, which you can do with PD-1. And then you need to address the stroma of the other tumor that's not irradiated. Because if you do all this right and the T cells can't get through the stroma, you're never going to see it. So as you see here, PD-1 just does one thing on step 5, where CTLA-4 addresses 3 of these issues. So CTLA-4, I think, is a very good drug. The immune response is super complicated. So in my lab, I have a postdoc that works on pretty much every cell, a Treg postdoc, an MDSC, myeloid, B cell Tregs. And just on the top left, you see the interaction of an antigen presenting cell to a T cell. Just by blocking one inhibitory interaction, thinking we're going to get a systemic immune response is not realistic. There's a lot of moving pieces here, and we really have to understand how all these cells work together, the right sequencing, if we're going to get a systemic response. Now, we all know abscopal responses do happen, and we've seen case reports like this one with CTLA-4. But what happened in the field when we were getting started is much of the preclinical work was done with CTLA-4, and then every trial at NRG was randomized with standard care with or without PD-1, without really the preclinical work and the sequencing being looked at. And CTLA-4 and PD-1 are dramatically different. CTLA-4 works in the lymph node. PD-1 works in the tumor microenvironment on the exhausted T cell. They're very different drugs and different mechanisms. I'm a big proponent of CTLA-4 for various reasons. One of the most important is the blunting of the Treg. So when you irradiate, you cause antigen release, which is good, but we increase Tregs, which blunt the response, and CTLA-4 can get over that. Point number 3, it can also induce memory, which in my lab is one of the most important things. If you can get memory, then you don't have to keep giving the drug. And that's the goal of what I'm trying to do when I do immunoradiation. So here's the first anaplastic thyroid treated in the world with a checkpoint. I actually got laughed at in tumor board when I did this. I didn't want to treat the one close to the heart because of cardiac toxicity, so I treated the smaller upper one, and the patient responded, and the tumor went away. Anaplastic thyroid, she lived for 18 months, which, with anaplastic, it's pretty impressive. So because of this positive patient, there's tons of trials now in anaplastic thyroid. Now, I can't prove this was an abscopal because she got the drug at the same time, but nevertheless, she had a nice response systemically with radiation. So I've done the trials with both CTLA-4 and PD-1 with radiation in lung cancer up front. And the PD-1 drug, as I'll show you in a minute, doubles the response. So checkpoint in lung cancer is about a 19% response. It goes to about 37% when you irradiate one site. But CTLA-4, which doesn't work in lung cancer, really only 4% response, goes to 23%. Systemic response. So here's a drug that is not even approved in lung cancer, but when you add radiation, you get a 23% response systemically. So I think CTLA-4 is quite important when used at the right time. I think we all know that Jimmy Carter had melanoma, and he gets credited with Pembro for being cured. But if you look at his sequencing, he had radiation and then cell therapy, and we've definitely seen case reports of stereotactic in the brain with checkpoints having better systemic responses. So I think this is where we are currently, right? If we're here with this simple bike of SBRT and we want to make this really cool dirt bike that does all this stuff, we're kind of piecing stuff together, right? We're bolting on an engine. It's not really working. We don't have a gas tank. It's not designed for it. So we need to figure out how to design trials for immunoradiation to get it to work appropriately and not just sticking stuff together, which will take time. CTLA-4, really good drug for abscopal. You see here on Marka Crittenden's work. But this one, sequencing is important. You've got to give it before, and then the radiation, which we showed in our trial. to prove the sequencing point, this is with OX40, and we did all the preclinical work in a mouse model, and we showed only after radiation does OX40 work. It's because of the bottom left, we turn on OX40 on the CD4 cells. And then the very first patient at MD Anderson who got an OX40 progressed and came to me. This was literally a month after I did the animal sequencing work. So I treated him exactly the same way, and I gave the high dose radiation and then OX40. And then here's an abscopal at the bottom left. So it does happen, but it's just getting it reproducible and consistent is where we're challenged at the point. PD-1, very finicky on how you give it. This, we designed these studies a long time ago, mine included, and now this mouse work's coming out, and very similar designs here. All they did is do the PD-1 before the radiation or after it, and dramatic difference. So the top one, you're priming, expanding, and then you address exhaustion, and 6 out of 8 mice are controlled. But if you do the same thing and the PD-1's given 1 dose before the stereo, it doesn't work. 13 out of 13 mice are tumor-free. And that's because you're expanding out the T cells, they come to the tumor, and then you kill them. So you don't want to do that sequencing, which we're starting to learn. And I think that's relevant for the case that was brought up this morning too. So here's Sean's study. And the sequencing, I believe they gave the PD-1 a little bit beforehand too, which could be problematic. I don't know if they got head and neck, if they had prior head and neck rads, but the big fields of radiation deplete lymphocytes and totally keep checkpoints from working. So that's a point I'll show later. So absolute lymphocyte count is super, super important, and we kill lymphocytes. So when I started my career, I was the PI on RTOG 0617, and I think we all know that study, higher doses of radiation was worse. How can 74 gray be worse than 60 gray? Well, because you killed the lymphocytes, right? And so we've shown this, as you prolong fractions of radiation, you kill lymphocytes and you can't get any immune response and you get worse local control. So here's our randomized study. We started this long time ago before PD-1s were even approved in lung. So we randomized between PD-1 and PD-1 with radiation. And Sean is right. When we looked at the group as they came in on the top left, Pembro stereotactic was a little bit better, but it wasn't significant. But the reason this study was really negative, it's really my fault, because what happened is people would come to me and they would need radiation. And so what I would do on some patients is I'd hit them with the radiation, and then once they were done, I'd randomize them. And the people who got radiation and then got into the arm of Pembro only did much, much better. And so if you look at the bottom of the paper, you see that. So we all know the Pembro response rate in lung should be about 20%. So on the top left, it's 34 or something. So that's too high. So if you look down here at the bottom, these are the people with the no radiation arm, but they did get radiation prior, and look at the response. So if you had radiation 6 months before you got Pembro, you did really well. And you see that in the PFS. And so that was my fault. It actually worked too well. I didn't think it would make that big of a difference. So if you put this all together of the people who really just got Pembro without prior radiation 6 months before with stereo, the stereo is better. And then what's interesting is the wide field radiation is worse. And that really surprised us. I knew 60 gray and 200s would be a problem, but this is 15 fraction. And it's because it kills the lymphocytes. And if you kill the T cells, there's nothing for checkpoints to work on. So just keep that in mind. All radiation is not the same. I think stereotactic is better. As Sean pointed out, what's interesting is the PD-L1 low benefit, which is kind of nice because if you respond to monotherapy, PD-L1's high, you don't need to add in the radiation, but we can turn the PD-L1 on and make these patients work where it's not working. So again, we did an analysis where we combined it with the Netherlands group, and really because we didn't have the statistical power, because about 25% of my people in the Pembro only arm actually got radiation beforehand. And so once we were able to put it with her data, and she didn't do that, she's a pulmonologist, so she wasn't irradiating extra stuff. And so once we combined it with hers, we did get a significant PFS and OS advantage in that group, which is nice to see that there's potentially benefit. And, survival is one of the most important endpoints. So, just my point on ALC. So I did this trials for a limited stage, extensive stage with Pembro and non-small cell, which I just showed you. I combined all those together to look at the abscopal response rate based on ALC. And this just comes out of the CBC. If you get a CBC and your ALC is above normal, you will abscopal 34% of the time, which is not trivial. That's a lot. If it's below normal, you get 3%. So I think ALC is one of the biggest biomarkers of abscopal. And you can come in with good ALC, but if you do too much radiation, you'll drop it down. Head and neck radiation is very problematic because of all the blood vessels and prophylactic areas you're treating. So I try to be very careful of that issue. So, we want to learn from our patients. And I have a patient that did abscopal in the trial I showed you. And what we were able to do is we hypothesized that they produced an antibody that led to that abscopal, and we could make that antibody into a new drug for new patients. So we started a company, and we took 10,000 B cells out per patient of people that abscopaled, and we found an antibody that changed macrophage polarization and just raised another $60 million around that. And that's now in human phase 1. So this is a drug out of a patient with abscopal turned into a new drug for new human beings to make them abscopal, which was really neat because we could have never found this drug target if we screened traditionally. So that's kind of learning from our positive patients and hopefully helping new patients with that. I harp a lot on the stroma because, as I started doing animal work, my first animal work didn't abscopal, and someone said, oh, it's really easy, just make the other tumor really small so there's no stroma, and it totally works. So if you do animal work, the stroma is the biggest issue because it's like a force field, a barrier for the T cells, and a T cell has to touch a cancer cell. And when we abscopal or try to, we're not doing anything for the stroma on the other tumors. And so that's something we really need to do. Now, you could fix that with drug, but you can also address it from complete metastatic ablation. So if you irradiate every single tumor and turn them all into vaccines, that's a strategy that works fabulously. Now, we've shown that in lung cancer. Dan Gomez had an oligomet study that's very positive, but we did that. This is a new study in people that are PD-1 resistant. Now, that's a hard area to treat. They're PD-1 resistant. We irradiated 3 or less lesions if they had a max of 3, and we compared it to standard of care, which here at MD Anderson would be a next generation IO. And look at the benefit, right? I mean, this PFS goes way up. So this isn't classic abscopal. I call this microscopic abscopal because there's microscopic disease without stroma, and we're very good at addressing that. So this is a great strategy when you can do it. I believe that's why the Pacific study is positive. This is one of the most positive studies with checkpoint, and it had radiation that addressed all the gross disease, so it only had to address microscopic. Again, I call this microscopic abscopal. Think it's real. So we are learning from our patients that don't respond, and we develop PDX models. So we take tumors before and after, we grow them in mice and try to study them and understand why they're not working, okay? And so we developed a model of pembro resistance a long time ago. And what we're doing now is we're testing new second generation immunodrugs in a PD-1 resistant model to see what really abscopals, and we make it as hard as possible. What we do is we make the other tumor that's not irradiated really big with a nasty stroma. And here you see top left, PD-1, of course it doesn't work, it's a PD-1 resistant model. CTLA-4 top right, a little bit better. Now look at the bottom. This is a new drug called GITR that depletes a subpopulation of Tregs. And the bottom left one is a depleting GITR, and the bottom right is the same antibody that doesn't deplete. And look at the difference. So if you deplete these Tregs that radiation is inducing, you can get pretty dramatic abscopals in mice. Now, Treg biology between mouse and human is very different. So I'm running this human trial, and we'll see if we get the same thing. We actually, make our own drugs as well for abscopal. If you think the CEO of Genentech and BMS are sitting there saying, how do we make an abscopal drug? No, they're not. They're trying to put us out of business. They want to make immunotherapy that works and doesn't need radiation, right? So no one's trying to make things for radiation that abscopal. And if anyone's going to do it, it should be the radiation oncologist, right? So we actually make our own therapeutics. This is a paper we published out of our PD-1 resistant model on a protein BMP that mediates PD-1 resistance. If you do shRNA on the bottom right, left, you see it works with PD-1 CTLA-4. It brings in the CD4s dramatically. And then the top right, it does abscopal as well. So now we're designing it because the drugs that we're using aren't designed for radiation. We're taking stuff other people does, try to shove it in and hope it works. But we should really design our own treatments that work. No one knows radiation and immune radiation better than us. Now, PD-1 resistance is a challenge, and this is a much harder setting, but this does show abscopal if you can get it to respond. Here's this trial I published where people are progressing on PD-1, you irradiate one spot, and you actually do see responses. There's about 11% response rate. So it does work, not a lot, but it does. But what's interesting here is, look, this is the majority of the patients, 73% have stable disease at 6 months. So these are people that are growing, you radiate one spot and they go stable for 6 months. So it's not an abscopal, they didn't shrink, but stable disease in the world of immunotherapy is important, and you can live with a long time. And it goes back to our case this morning. I probably wouldn't radiate that. They're stable, they're probably responding. So stable disease is a good thing. And people on PD-1 can live with stable disease for like 12 years and not progress. So when I did the CTLA-4 study, I saw this interesting case of this large tumor in the middle that totally responded, which you'd think is an abscopal, but it was only one tumor, and the tumors below it didn't. And so when I looked at the radiation plan, I realized low dose radiation from the top tumor touched it and made it respond. And I found 40 cases of the same thing. This is a PD-1 resistant melanoma. I didn't irradiate the spot in the red. It got scattered, it disappeared. So what we do is we have a concept called Abscopal where we do high and low at the same time. So 1 or 2 tumors becomes a vaccine. All the other tumors get low dose to produce chemokines to pull in T cells and address that stroma. Here's the first patient in the world I ever did it on. You can see the nice response in the abdomen. He's NED now, several years out, and he's never progressed. This is a really nasty one. This is head and neck radiation after 70 gray. So we know that's nasty stroma. He progressed on PD-1. They sent him to me. Obviously, you can't get full dose in there after 70 gray. So all I did is low dose to his neck with a stereotactic in the lung. And now what I do is biopsies pre and post low dose to prove I'm pulling in T cells. And if you go to SITC in the big immune conferences, if you can increase CD8s by like 10, 15%, everyone gets excited. So top right here, these are biopsies 1 week before and after low dose radiation. The CD4s go up 400%, CD8s are up 400%, NK cells, which kill without MHC class 1, are not even present, and they go up 1300%. So not only does low dose pull in the activated CD8s, it pulls in the helpers and the NKs. So low dose is a really cool trick that's safe, easy to do, and can help. Here's our trial on Abscopal, 55% response in PD-1 resistance, now that we're addressing that. So we now can define Abscopal and Abscopal responses based on PET, which you see here. And so this helps me a lot, because when someone comes to me, I can figure out where to do the high and the low dose based on their PET. And biologic guided radiation is being developed at Ames, radiation based on PET. So this will be like a self-driving linear accelerator. And it's really hardware for Abscopal, Abscopal, or complete metastatic ablation. We can use the low dose for cell therapy to pull it in and fix that now. We're pulsing Abscopal like multiple COVID vaccines, so doing it a couple times. And the big NRG study will take all lung cancer, randomize them with or without Abscopal. And then the last thing is we're adding in nanoparticles to get immunogenic cell death to work much better. And now we get memory, we get massive memory. So if you want immunogenic radiation, you add this nanoparticle, it helps. So it took 100 years, right, to go from Madame Curie with brachytherapy. If you catch Brian Kavanaugh on the weekend, this is what he looks like riding his dirt bike. But it took 100 years to go from brachytherapy to Brian Kavanaugh doing stereotactic. It takes a while. And in the first 4 years, we do show some Abscopal, we have prospective data and low dose modulation. But really, the exciting part's what's coming. Now we have new trials with Treg drugs. We're doing pulse Abscopal nanoparticles. And now I figured out ways to get protons and heavy ions to work better immunogenically. That'll be something in the future. So I'd just like to thank my lab and all the people who helped, the rest of the people in my thoracic group who put people on this study, and I'll stop there. Thank you.
Nice job, Dr. Welsh, right on time. So now, Dr. McBride, you'll have 10 minutes for your rebuttal.
Thanks, everybody. That was an excellent presentation, Jim. The work that your lab's doing is really impressive. I mean, I think I don't think I'll take the entire 10 minutes to rebut. I would just make a couple points. One, I am a fan of complete metastatic ablation, but I think that's an entirely separate paradigm from Abscopal, and I'm sure Jim would admit as much. I think that is an additive benefit, not a synergistic benefit between IO and RT. Just we're ablating all of the gross disease that we can see in oligometastatic patients, and that the patient derives a benefit from that just by the sheer elimination of various clones that could promote progression at some future point. I don't think might that have something to do? Might there be some synergy? Sure, but I think we have a sort of a simpler explanation behind the benefit you see with complete metastatic ablation. The other thing I worry about is that as we make the claim that we need to add more and more IO drugs to radiation in order for radiation to have some benefit, the question, each of those IO drugs is adding marginal benefit. And eventually the room for any effect size improvement from radiation is going to be so narrow that it'll be frankly meaningless. So when we say, yeah, and there's a lot of excitement about non-fucosylated anti-CDL4 monoclonals because they're going to be Treg depleting. But again, traditional anti-CTLA4 is Treg depleting, and we have Jonathan Schoenfeld's trial that was stone cold negative with the addition of Tremi to RT in patients, who are progressing on PD-L1 therapy. The final question of the Abscopal, I think that's a very exciting concept. But again, I think that's something obviously separate from what we're talking about. That's whether, IO and very low dose radiation can produce substantial and sustained responses in the tumor that's receiving the low dose radiation. Whether that translates into hard endpoint outcome improvements like OS, I think Jim's trial is outstanding. That trial may very well be positive. But again, I think when you look at the totality of the data, outside of post hoc analyses, which are suggestive, but oftentimes contradictory, again, because in all of the standalone randomized trials we've run, all of our hypothesis-saving conclusions fall back on, well, maybe it's the immune cold. But again, in Jim's meta-analysis, that fell off. We no longer saw that PD-L1 levels that there was a differential response depending on PD-L1, meaning the PD-L1 cold were the ones that were benefiting. We didn't see that in the meta-analysis. So, I'm not optimistic based on the randomized controlled trials. And this extends outside of Abscopal. We now have multiple head and neck trials in the definitive setting that were negative. Now that may be because of the point that Jim made about ALC and the broad field elective nodal irradiation. We also have a cervix trial that was stopped early now because of futility. So, I am, again, the totality of the data doesn't make me enthusiastic about the future of Abscopal. Complete metastatic ablation, yes. Abscopal, potentially. But I think Abscopal is, the nails are in the coffin.
Sean, can I add one thing? Your point about the multi-immunotherapies is right. It's going to be a challenge, but I actually think this is where radiation might have an advantage. If you look at what a Rad Onc does, they do the same thing every time. Address exhaustion, exhaustion, exhaustion. Hit Tregs, right? They do the same treatment in cycles every 3 weeks. But as we all know with immunotherapy, it's a cycle, right? Antigen release, priming, activation, exhaustion, da, 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 da. And I think the beauty of radiation is we start the cycle. And so the way I think there will be a future of multiple IOs with radiation. And we know when you add two together, CTLA4, it's expensive and toxic. But the way I view it is, if everything centers around radiation, and we're radiation oncologists, so we can say that, I think the way I think about it is, what do you want to add before the radiation? What can you add to the tumor to make it more environmentally friendly? Maybe deplete Tregs right before you add your antigen release. Do your antigen release, you could potentiate that, and then things to your dendritic cell is right after. So I'd call it the radiation sandwich in my lab, and I want to know the drug before, the drug with, the drug after, and if you use immunotherapy that way, it's less expensive and less toxic because you don't have overlapping. Now, it's hard because sometimes you need multiple drug companies to hit those different slots, but I think that's our advantage. We can deplete the Tregs when it's important to deplete it, where Rad Onc just depletes every 3 weeks, right, and no cycling effect. So that's a part that's challenging to work on, but I think an area that we might have some opportunity to look at and make things better at.
No, I think that's a point well made, Jim. But I do worry that as we, I think the radiation has toxicity advantages compared to IOs. But again, if we're doing multiple IOs in order to get that benefit from radiation, then I think we are I think the magnitude of the benefit we can provide will shrink and shrink and shrink.
Yeah.
All right, excellent rebuttal to the rebuttal and discussion.
It's a recursive loop of rebuttals.
I'll also throw in a tangent, Dr. Kavanaugh, I vote for the Jeff Goldblum background. That was excellent. All right, Nav, can we actually repoll the audience just to see if they were swayed one way versus the other? We can just do another 10 seconds.
I'm trying to rock the Jeff Goldblum glasses from Jurassic Park.
I was trying to get a
Mission
younger Jeff
accomplished.
Goldblum picture with glasses, but I couldn't find a young, no beard with Jeff. You know,
I know.
But
I have tons of those backgrounds.
And then after that, can we talk about the case? Because I have some kind of thoughts on that case.
Yeah, of course. And it looks, I actually can't remember the split initially. I thought it was initially around 50-50
Yeah.
pro radiate. I think it's about the same.
That Welsh charm, my goodness. Yeah.
Well,
in fact,
so
that's an X
it's a
factor.
good thing
I'm just gonna have to rely on
the choice on there.
Yeah. I'm gonna have to rely on the insurance companies to rein this in.
Well, it's a funny result because I actually don't think you should irradiate this person. And I'll tell you why. So it's an interesting case, and it's kind of that middle ground. Now, back in the era of TKIs, where people were progressing, and think about Ross Camage, Brian, and the work they do there. Like, the TKI era, there were resistant subclones, so hitting everything with radiation after made a lot of sense because you're going to get those out. But in the immuno response here, I like challenges, right? I want someone who's progressing on PD-1 and try to get them. This guy, I think, had a residual disease and was kind of just stable there. But we know from people with the PD-1 and CTLA-4 state, people can have residual stable disease for years. I've seen people not abscopal for 2 years, and then they start to abscopal and get smaller. So as long as it's stable, I wouldn't get in there. And the reason being, like, first rule of medicine, do no harm. The reason it's stable is because there's T cell there's working, keeping it stable from growing. And you don't want the radiation to kill those, right? And so I would probably just watch this patient until they're progressing. And then once it's progressing, that's the tumor to make your vaccine. That's the one with the weird antigens or something's different that you can make the vaccine. The other important things is he was on lenvatinib. You got to be really careful with that with radiation. Now it was stopped, but there can be vascular things in that hilar area. It was weird. You could do high dose to the chest wall and then low dose, you could radscopal him. But the last point is he was on steroids, right? Dealing with that toxicity. And I don't think you can prime someone when they're on steroids. And BMS has some data, I don't think they ever published it, but they showed me, if you take someone on steroids and then give CTLA-4, it doesn't work in a mouse. But if you do CTLA-4 and then the steroids, it does work. And the point being is, I don't think you can prime when you're on a steroid, but after you've primed, I don't think the steroid's that problematic. So for this patient, I would probably just wait a little bit, see if they progress, and then get them off that steroid, because I think the steroid could be a little bit problematic as well.
I have a question, if that's okay.
Oh, yeah.
For either anyone. Of course, a lot of us get our news from Quad Shot, right? We all do, right? Let's face it. And then earlier this week, they had a nice link to the paper recently from one of the British groups showing absolute lymphocyte count as being an adverse, low absolute lymphocyte count being adverse for oropharyngeal cancer treated with RT. And I mean, there seems to be sort of a dearth of literature. Maybe I'm ignorant of it and I don't see it, but that as the most simplistic biomarker of all with immunotherapy. I mean, is there some canon of literature I've missed, just not neglected or something like that just relates absolute lymphocyte counts with prediction of immunotherapy durability, or have I just been lazy and missed all that, or anyone know?
I'll go. I think it gets missed and not talked about much. And I remember when I was in the closed door room at NRG and they showed the higher doses of NRG with 74 gray was negative. And everyone's like, how, right? 150 BED is better than 60 BED. How can 74 be wrong, right? And I remember thinking we started looking at the lymphocytes, and this was years ago, and everyone kept asking me, what's a lymphocyte? Why would lymphocytes matter? And of course, this is before checkpoint. So I think it's really important. And there's a lot of papers that have come out again and again and show this. So we've shown it in I've done 6 immunorad study, and every single one, ALC is the most predictive aspect. And I think in the NRG study, we will stratify based on that. And it's also important when people are pre-treated with chemo and different things, that lymphocyte count could be quite a bit lower and stuff as well. So, and what to do to fix it, Brian, we actually put a paper out, like if the lymphocytes are low, you can't get an immune response. So you do complete metastatic ablation, right? But if that's where cell therapy and things, or IL-2 or cytokines come in, there are ways to try to increase the immune cells. Steve Lin at our group here has an interesting study where he takes the lymphocytes out and then he does chemo rads and then puts the lymphocytes back in afterwards. So that's pretty cool as well.
I would just say on the ALC, I think the question here is whether ALC is somehow differentially confounding the trials of, IO plus minus SBRT. And I certainly would agree with Jim that, that reductions in low ALCs are going to blunt an immune response, whether it's IO monotherapy or whether it's IO and SBRT. But I don't think the explanation for the null trials is that there was some, confounding by ALC, because in my mind, that ALC would confound both arms equally, if it's even present.
And Sean, what makes it hard is like when we started these studies up front, we could get newly untreated patients with checkpoint.
Yeah.
That era is gone, right? The era we're in now, people are pre-treated, they're on multiple IOs. And so it's much harder for radiation to add value, clearly to that point. So it's getting harder as the immunos progress and get into the field for sure.
Yeah, that's definitely true. That's what makes me so concerned about Schoenfeld's trial. Those patients were progressing. That is a place where we could have conceivably added value. Yeah. And even with the CTLA added to the RT, we didn't see it.
An interesting thing on his study, he had low dose, but for us, low dose by itself doesn't work. We can take a mice and do low dose, it just doesn't work. You have to prime and then pull in those cells. So the one shot of low dose is just not enough. But with cell therapy is a cool thing, right? Because you have billions of activated cells and they can't get through the stroma. And so we try to fix that with the low dose and pull it in, which is a different topic. But cell therapy can potentially address this ALC issue in a very unique way.
Oh, that's a good point.
All right, so I'd seen one question in the chat, and apparently there was a longer one in the Q&A, so we can do the chat question first and then go into the Q&A. So there was just a question directed to Dr. McBride, but I think we can get both of our speakers to weigh in on what PD-L1% cutoff is important.
I am not, Nick Zaorski asked a great question. His group had the great meta-analysis looking at the abscopal, the case reports of the abscopal effect, and it was really well written and well done. So I'd encourage you to check it out. But I think, Nick, my view is that I don't think there is a differential response to SBRT IO versus IO alone based on PD-L1 status. We didn't really see that in our own trial, and I think Jim's meta-analysis that doesn't really that doesn't appear to pan out. So I think obviously there's the separate question of what are the PD-L1 thresholds for response to IO, and that differs, I think, by histology. But as to whether or not there's a differential impact of radiation added to IO based on PD-L1 status, for me, the data doesn't suggest that.
Yeah, totally agree with Sean. For us, all I focus on is on PD-1 resistance. So at that point, who knows what the role of PD-L1 status is at that point. And Steve Lin has a trial with that, I think with NRG, where they're doing it in the PD-L1 low patients and trying to stratify. But it's really challenging because it takes a long time to get that tissue and look at it and then put the patients in. So even though that's a nice thing to put into the trial, it causes a lot of accrual challenges. And it's dynamic, it changes, right? I mean, you can have changes with, I've seen trials where radiation increases the PD-L1 level in the tumor as well. So I don't look at it routinely. If anything, we look at the ALC level, and then we really try to study the Treg populations before and after and see how radiation's affecting that. Because there's a lot of Treg drugs out right now, and that's clearly a problem that radiation is inducing. So that's what we focus on.
And Dr. Welsh, there's a QA question, if you're able to view that. Somewhat
No.
long.
Okay. Yes, I'm reading it. Thank you for the comment, Dr. Welsh. That's a long one. Targeting T cells alone may not be enough to overcome.
Let me explain the context why he's looking there. I've been to Jim's office. It looks like NASA headquarters in Houston. He's got 17 screens up. They're all 64 inches in diameter. And so he's looking at a lot of stuff right now. So that's why he's looking up. And
yeah, I do. I'm on a
giving you some
65-inch computer monitor. So it's
yes.
There have been several.
Mission control is where he is right now.
Yeah, so I mean, this is talking about the M1, M2 aspect on the macrophages, and I think that's a very hot area right now. So, 5-6 years ago, there was a lot of focus on Tregs, that stuff starting to get in the clinic, and then the macrophage polarization is a huge issue right now. And the antibody that we found that is now a drug in human patients, it changes macrophage polarization. And what was so interesting is you could have never have found this traditional ways by finding ligands. The way it binds to a receptor in a macrophage, it changes in the body, makes a conformational change, what makes it go to M1 polarization. So M1 macrophage polarizing drugs, I think, are going to be kind of the next really cool area to start studying with radiation. And that will help probably in both tumors, right? And that's the thing about Tregs too. If you deplete the Tregs, it helps in the radiated tumor and in the non-radiated one, and the macrophage polarizing drugs can help there too. So we're starting to see more of those, and I think that's going to be a good area to study and look at with radiation. So yeah, good question.
I also had a question, so for Dr. Welsh. So we kind of discussed how nuances likely matter in these situations, the timing of the radiation immunotherapy, the type of immunotherapy, the dosing. You brought up how, the higher ablative dosing may actually deplete, the immune cells, lymphocytes. So to summarize, what do you think is an ideal patient scenario for eliciting Abscopal?
Yeah, good question. So, 5 or 6 years ago, there's so many questions, right? And I think basically everything we do with radiation needs to be optimized for immunorads. The fractionation, the sequencing, the technique, even things like grid could actually be a lot better because you're not killing the immune cells. And so a couple of years ago, we're really trying to focus on what's the right dose, right? And if you're curious, I'll tell the resident why I do everything with 50 gray and 4, and then Sylvia Fermenti has her 9 gray times 3. So I call it my dose and her dose. And the reason, guys, I use that dose is because we ran the STARS trial with Joe Chang, he's probably on the phone, and we randomized people between stereotactic and surgery. And we saw people with stereotactic had less distant failure. And that was just without IO, right, for stage 1 lung cancer. And so I thought there's a good dose. It looks like it does something immunologically. And I wanted my work in stage 4 to bridge to all stages, including stage 1. So if I did it in a lower dose of radiation, Joe Chang couldn't take that to stage 1 cancer. And, because the dose would be off. So that's why I stuck with that 50 gray and 4. When I did the combined paper with the Netherlands group, the goal was to really see if 50 gray and 4 is better than like 9 gray times 3. And we showed that the MD Anderson patients probably did better, but it's something Sean brought up beforehand. I irradiated multiple lesion, and the Netherlands, is led by a non-Rad Onc. She only irradiated 1 spot. And I think that's what led to our patients doing a little bit better, having a little bit more tumor, a little bit more vaccine, so to speak. So to your question, I think the perfect scenario is someone up front who hasn't been treated a lot, right? ALC is still going to be good. If you can get them on a CTLA-4 with stereotactic to a decent sized tumor, lung and liver, I think then you have a nice chance. And then a little PD-1 afterwards would be good to address exhaustion. So that's, I think, a good scenario. Those are harder to come by because med-oncs try them up front and then send them to us. And then we have to kind of, as we saw in the case. So that's my perfect scenario. And then the other thing is tumor type, right? most of my work is melanoma and lung. Those work good for abscopal. There's good antigen release. And now that I specialize in checkpoint resistant, I get all the worst tumors and I get colorectal and I get massive amounts of uveal tumors that are metastatic to the liver that don't respond to checkpoints. So the world I'm living in now is really, really hard people to get them to respond, where I'm trying a lot of creative things. But, you know, good antigen producing tumor, lung, melanoma is a good thing to start off with to increase your odds versus a colorectal or a pancreas.
Excellent. Thanks so much, Dr. Welsh. Thank you, Dr. McBride. So just to wrap up here. Well, I guess you can just see these last two slides. It's fine. I just want to say thank you to all the panelists and to our ROVER coordinator, Navjot. Please be sure to fill out the post survey, so you'll get an email link for that, and it helps us to improve these sessions. And just for future sessions, you can go on to our radoncvirtual.com and see what's coming up. But thank you all so much. We finished right on time. So thanks again to the panelists and speakers, and have a great weekend.
Thank
Thank
you.
you.
Thanks, everybody.